One of the most fascinating and somewhat unsettling discoveries in modern biology is that cells don't just respond to environmental stress in the moment, they can actually be permanently changed by it. This phenomenon, often described as cellular memory or stress-induced reprogramming, helps explain why exposure to UV radiation years ago can still affect your cancer risk today. It's not just about damaged DNA persisting. It's about cells being fundamentally rewired by the stress they've experienced. When a cell encounters significant environmental stress, like intense UV radiation, it activates emergency response programs. These programs change which genes are active and which are silent, alter how the cell uses energy, modify how it responds to signals from other cells, and adjust how aggressive its stress responses are. In a short-term stress situation, these changes are temporary. Once the stress passes, the cell returns to its normal programming. But with repeated or severe stress, something different happens. The changes start becoming permanent or at least very long-lasting. This occurs through mechanisms called epigenetic modifications, which are chemical changes to DNA and the proteins around it that don't alter the genetic code itself, but do change how that code is read and expressed. Think of it like highlighting or dog-earing pages in a book. The words don't change, but you've marked certain sections to be accessed differently. In skin cells repeatedly exposed to UV radiation, these epigenetic changes accumulate. Genes involved in DNA repair might become less responsive, meaning the cell is worse at fixing damage over time. Genes that promote inflammation might become more easily activated, meaning the cell is primed to create an inflammatory environment. Genes that control cell division might have altered expression patterns, making the cell more prone to inappropriate growth. What makes this particularly concerning is that these changes can be inherited when cells divide. When a stress-modified cell divides, its daughter cells carry the same epigenetic modifications, even if they're never exposed to the original stress. You can end up with populations of cells that are essentially programmed to behave abnormally based on stress their ancestor cells experienced years earlier. This is one reason why early life sun exposure has such long-lasting effects on cancer risk. It's not just about mutations, it's about reprogramming cellular behavior in ways that persist through many generations of cell division. The concept of cellular memory through environmental stress extends beyond skin cancer. It's been observed in many biological systems and helps explain various phenomena, from how stress affects development to how the immune system adapts to repeated challenges. But UV radiation and skin cells are a particularly clear example because the exposure patterns and outcomes are well documented. There is a more hopeful angle here, though. Understanding that cells can be reprogrammed by stress also opens possibilities for reprogramming them in healthier directions. If chronic stress creates harmful epigenetic patterns, then perhaps we can develop interventions that reverse or prevent those patterns. Some research is exploring whether certain compounds or lifestyle factors might protect epigenetic programming or even restore healthier patterns after damage has occurred. From a practical standpoint, this cellular memory phenomenon reinforces why early protection matters so much. The sun exposure you get in childhood and adolescence doesn't just potentially mutate your DNA, it potentially reprograms how your skin cells function for decades afterward. Protecting children and young people from excessive UV exposure isn't just preventing immediate damage, it's preventing the establishment of harmful cellular programming that could persist throughout their lives. It also helps explain why stopping sun exposure later in life, while definitely beneficial, can't completely eliminate risk from earlier exposure. Those cells have been rewired, and that rewiring doesn't simply disappear when you start using sunscreen. Prevention from early in life, before harmful epigenetic patterns become established, is the most effective strategy. Environmental stress can rewire cells in ways that persist long after the stress is gone, which is both a warning about the lasting impact of sun damage and motivation to start protective habits as early as possible.